Right, here we go. Hopefully we're live and recording this. Today's stream is going to be basically on trigonometry using sine and cosine rule and looking at 3D trig. So here's our first couple of questions. I'm going to give you 3 minutes to see how much of this question you can get done. Okay, starting from now. Okay, so let's have a look at this question then. What we've got here is we've got an angle opposite a side, and then we don't have a side opposite this angle, and we have a side but no angle. Or do we? Actually we do, because we got this angle because we can take these two away from 180, so add 76 to 52, and we get 128. Take that away from 180 and we get 52 for this value here. So now we've got opposite sides here and angle, a side opposite an angle, we can use a sine rule. So x over sine of 76 equals 4 over sine of 52. And we can do x equals sine of 76 times 4 over sine of 52. Grab a calculator and we do sine 76 times 4 divided by sine of 52. We'll get an answer of 4.925. So that's 4.921 decimal place. And this one, we've got all the sides and we've got an angle. So it's just a straightforward cosine rule question. Depending on how you remember your formula, if you can't remember the one for the angle, you can just start off with the standard one on the formula sheet. Put the numbers in and then rearrange. It's quite useful to remember off by heart what cos A equals. Saves you all the time of having to rearrange this, but we'll just go through it because there's a very common mistake that people make when doing it this way. So 5.8 squared, let's grab my calculator. Yeah, 5.8 squared. Actually, what I'm going to do is I'm going to do a bit more maths first. 5.8 squared minus 2.6 squared minus 3.7 squared equals minus 2 times 2.6 times 3.7 cos of A. And I'll work this bit out and carry on working on the calculator. So we're going to minus 2.6 squared minus 3.7 squared. That's equals, I get 13.19. Work out the other bit. And I get, minus 2 times 2.6 times 3.7. And I get minus 19.24 here, cos A. So cos A will be 13.19 divided by minus 19.24. Now the common mistake that people make, which I haven't talked about, is to actually just work out 2.6 plus 3.7 minus all of this and think you've got all of that times cos A and forget there's this minus in between and this plus in between. And we have to take that away, then we work, there's only that bit here, 19.24 times cos A, which is the common mistake made here. So let's finish off with the calculator. So we've got 13.19 divided by the answer equals, press inverse cos of that answer, and we get 133.27 degrees. So that leaves us 133.3 degrees to 1 dp. Right, how about this question? Give you 2 minutes to have a go at this one. Notice it says the exact value. Okay, so let's have a look at this one. We've got two sides and we've got an angle, we've got a side opposite that angle. When you've got the two sides, either side of the angle and that side, we can use the cosine rule. We haven't got enough extra side opposite an angle to help us use the sine rule. We need at least one pair which the side and the angle are given for use the sine rule. And we don't have that, so it must be cosine rule. So z squared is equal to 7 squared plus 15 squared minus 2 times 7 times 15 times cos of 16. That's 49 plus 225 minus 2 times 7 times 15, that's 14. That's going to be 210 times cos of 60, which is a half. And you're supposed to know that for your GCSE. So therefore we've got 49 plus 225 minus 105. That's going to come to 169. So z squared equals 169. Z must equal square root of 169, which is 13. Our next question. I'm going to give you 3 minutes. See how much of this you can get through in your 3 minutes. Okay, so here we go. So we've got this triangle 90, 2, 4, 5, 16. We want to calculate pH. So that's just going to be a standard cosine rule question. So we've got a squared, we use the formula a squared equals b squared plus c squared minus 2bc cos of a. We call that our a and that our little a, and then this is b and this is c. So a squared will equal 90 squared plus 245 squared minus 2 times 90 times 245 times cos of 16. Grab a calculator. And we just type that all in. Nice and easy. And we get 25733. Point all the rest. 3, 5 and so on. And then we're going to square root that. Grab a calculator again. And we're going to square root the answer. Not twice. And we get 160.41. So our answer to the nearest integer is going to be 160 meters. Now on the next bit, we want to find the angle PHT. So PHT is this angle here. So we're going to do sine of h over the opposite side 90 equals sine of 16 over this side we just worked out 160.41, but you would put all the values into that. So when we grab our calculator, over here, so we're going to do, we've got that number still there, we're going to do sine of 16 divide by the previous answer equals times that by 90, and that gives us what sine of h is equal to, about 0.15. And so therefore we're going to inverse sine that answer to find out what h is. So shift sine answer equals 8.89. Notice I don't do any rounding of any of my numbers on the way to the answer. I only round at the answer is the only time. Now we want to find the area of the triangle HPT. So we just use the area formula. So the area equals a half AB sine C. So the two sides either side of the angle. So these two sides are either side of that angle. So it's just simple of chucking it straight into the formula. Half 90 times 245 sine of 16, and you just throw that straight into the calculator. It's not a terribly difficult question, but it is level 6 and 7 standard. If it was a level 8, 9 questions, there'll be a lot more rearranging going on. All you're doing is remembering the formula and putting it into the formula. I get 3038.9. And you don't need to see me square, and that is our answer. We're going to round it to the nearest whole number, so because it's 0.9, we're going to go up by 1. 3039. Okay, here you go. I'm going to split this up into 2 parts. I'll give you 2 minutes to just do the first bit, and then 2 minutes to do the second bit. If you get ahead, feel free to have a go at it. But I don't think it's all doable in the 3 minutes, which is my biggest timer. Okay, so what do we have here? We have to find the length of B here. Now what we can realise, because it's a cuboid, this length is the same as this length and this length and this length. They're all 6.9. So that there is 6.9. And this one's also going to be 4.7. And we want to find the length here of B to E. If we draw out that triangle as a right angle triangle, we can see we've got B here, we've got A here, and we've got E here. And this is 4.7 and this is 6.9. So therefore BE squared will equal 4.7 plus 6.9 squared, which gives me, use a calculator, we go, cancel 4.7 squared plus 6.9, not cubed, squared. And should I get it in the right place? There we go. And we get something like 69.7. And square root that. This is 8.34. So to 1 dp, 8.3. Actually, that was the, sorry, I forgot that was the easy bit. This bit will definitely take you the time extra time you'd have had on the last question plus the time you got now. There you go, another 2 minutes to finish this question off. Oh, sorry, I didn't see, I hope you remember the question, I didn't see that disappear from view. See if I can get it all back again. Right, it's all my working previously. Right, I want to calculate the angle that BH here makes with the plane ABFE. And we do that by using this right angle here. So actually this isn't going to be a long question. Sorry, I thought it was going to be ABDC. You had to work something else out first. They're giving you the side that you had to work out fast because we worked out BE. So this is actually a right angle triangle because this is a plane and this side is obviously perpendicular to that side of the cube. So if we can write out that triangle HE and we got B here, we know that HE is 11 and we know that BE is what we worked out here, 8.34, except we're going to use all the numbers in our calculation. and we want to find the angle that BHE makes with the plane. The angle we're looking for is that angle here. So it's the angle HBE there. So we can see that tan theta will equal 11 over 8.34 and all the rest. Oops, sorry, I've gone to the next question. Didn't mean to scroll down that far. So theta will equal, let's grab a calculator. We've still got the 8.34. So if we do 11 divided by our previous answer to get that, and do shift tan of that answer, we get 52.8 degrees. And we want this to the nearest 1 dp, so I need to just read that again. It's 80. So we get 52.8 degrees. Right, this question. Let's see if you can find these two lengths in 3 minutes. One length, one angle. Okay, so we've got STUV's cuboid. We know that M is a midpoint here and N midpoint here. So if this side is the same as this side, which is 8, that distance MV is going to be 4. And this distance here from N to U is going to be half this 6, which is 3, because all these heights are going to be 6. And we want to find the length of MN. Well, first of all, we need to find the length of MU here, because then we can use Pythagoras with NU to find it. So we find the length of MU by doing MU squared will equal 4 squared plus 17 squared. I don't know what's going on here. 4 squared plus 17 squared. I'm just going to close this app down and open it again. Just give me a second. It tends to help it. Get it back. It starts misbehaving like that. It often helps to just reload it. Okay, let's just go back to this corner. So we've got 4 squared plus 17 squared. And that's going to equal, we square root, we just put it into our calculator. Read off. So we've got 4 squared plus 17 squared equals square root of that equals square root of 305. Wants it to one decimal place, so it's 17.46. So it's going to be 17.5 is our answer. No, so it's MU. So we need M. I haven't quite finished the question. So that's our MU. Now we know that this is going to be the square root. I'll just grab myself a pen. And this is the square root of 305, makes life easier. So therefore we know that MN squared will equal root 305 squared, which is 305, plus 3 squared, which is 9. So it gives me the square root of 314 for MN. Put that into our calculator. And we do square root of 314, and we get 17.7. Now we want to find this angle NMU, so this angle here. We know this is a right angle, so we can draw that triangle out. There's N, there's U, there's M. And we already know that this is going to be the square root of 314, and we know the height of this is 3, so we've got theta here. So we've got opposite over hypotenuse, so sine of theta will equal 3 over root 314. Grab a calculator, and we do 3 divided by the answer, gives me that, shift sine answer, gives me 9.747. 747. That's going to be 9.7 degrees to one decimal place. Right, last question, 3 minutes. See how far you can get with this question. Okay, so here we go. We've got to find the length of AE here. And you can see the height of this is 16, drops down to the base, which creates a perpendicular with this edge here that we can use to find AE. But first of all, we've got to find the length of this point from here to here. And if we draw a right angle out from here, we can see this is going to be, if that's going to be dropped straight down, this is midpoint of the base. So point E directly above the midpoint, then that's going to be halfway along here and halfway along here. So this will be 3 and this will be 5. So we can find the length, we'll call that x, of AX squared will be equal to 3 squared plus 5 squared. So it's going to be 9 plus 25 is 34. So AX will be the root of 34. Now we want to find AE. So AE squared will equal this side squared, which is 34, plus 16 squared, the height 16 squared. That comes out as 256 plus that gives me 290. So therefore square root that, grab the calculator, I don't know the square root of 290. Square root 290 and we get 17.02, which is 17.0 to the nearest decimal place. Okay, 17.0. Now we want to calculate the angle the plane ECB makes with the base ABCD. So I'm just going to rub out, just look, ECB. So we're going to calculate the angle the plane ECB makes with the base here. So that means we need to find the line that joins them. And where the line joins them, we need to find the angle between two lines which are at right angles to this. Now this line is, and this line are not, this line's at right angles to this base, but this line's not. What we do is we draw down the middle here. Okay. And that will create, that will be at right angles there. Okay, and this will be at right angles here. So therefore these two lines are now both in, that's in that plane, this is in this plane, and they're both right angles to that edge. And that is how you find this angle, because there's lots of angles here along this side. We want to find the smallest one. That's how you find the smallest one. So we know this length here is 3. We know this height here is 16. Okay, so we've got our triangle and we want to find this angle theta. So therefore tan theta will equal 3, opposite over adjacent, so I'm doing this the wrong way around. That's going to be 16 over 3. Grab our calculators. And do 16 divided by 3 equals fifth tan of that answer. And we get 79.38 degrees. To the nearest 1 dp, we'll round up and make that 79.4 degrees. And that's all for today. Tomorrow what we'll be doing is looking at the level 8-9 versions of these questions, which are not so straightforward. And you don't just put the formulas in and get the answers out. You have to do a bit of rearranging and applying the formulas and the knowledge to the questions in tomorrow's session. Excellent. Thank you very much. I hope you enjoyed that.